Hello everyone and welcome to Ved Foundation. I am Yogita Dhande, competitive exam coach and founder of Ved Foundation. Today we are going to learn about something very interesting and that is present all around us but we cannot see it with our eye, and that is electricity. Have you ever experienced a small shock when you fold a blanket? Or have you seen lightning flashing in the sky during thunderstorm? That is static electricity. On the other hand, the appliances that we use in our home run on current electricity. So in this lesson, we will understand what is static electricity and how it is formed, and what is current electricity and how it is useful to us in our daily life. So let us start. Electricity. So electricity is a form of energy produced by presence of charged particles like electrons and protons. Static electricity. Static electricity is produced when suitable combination of substances rub against each other. Suitable combination of substances like glass rod and silk cloth, ebonite rod and woolen cloth, sealing wax and wool, plastic and dry hair. Static electricity is developed due to frictions, so it is also called friction electricity. Static means stationary. The charge produced remains on the object and do not flow, and that is why it is called static electricity. Charges developed due to friction. When glass rod is rubbed on silk cloth, positive charge develops on glass rod and negative charge develops on silk cloth. When ebonite rod is rubbed on woolen cloth, positive charge develops on woolen cloth and negative charge develops on ebonite rod. When plastic comb rubbed on dry hair, positive charge develops on dry hair and negative charge develops on plastic comb. Electric charge. Electric charge is a fundamental property of matter. There are two types of electric charges, positive electric charge and negative electric charge. The scientist Benjamin Franklin named the electric charges as positive charge and negative charge. The two opposite charges are always present in all substances. When the positive charge and negative charge on an object are balanced, then no net charge present on the object. That is, the object is neutral. Let us know how charges are formed. When equal positive and negative charges are present in an object, the object is neutral, neither a positive nor negative. If the charges are not balanced or not equal, the object is said to be charged. Transfer of electrons create positive charge on the object, which delivers the electrons, and negative charge develop on the object, which receives those electrons. When two objects rub against each other, the negatively charged particles on one object are transferred on another object. The object to which negatively charged particles go becomes negatively charged due to excess of negatively charged particle or due to excess of electrons. The object from which the negatively charged particle go away become positively charged due to deficiency of electrons. Test for identifying electrically charged object. Repulsion is the sure test for identifying an electrically charged object. There is always attraction between unlike electric charges. Means there is always attraction between positive and negative electric charge. And there is always repulsion between like charges. There is repulsion between positive electric charge and negative electric charge. Electrically charged object attract uncharged object as well as oppositely charged object. So attraction can't be the sure test for identifying electrical charge object. But repulsion only between like charges. So repulsion is used as test for identifying an electrically charged object. Generating electric charge by induction. When an uncharged object is brought near a charged object, an opposite charge is generated in the uncharged object by induction, and both the objects get attracted to each other. On touching, both the objects become similarly charged and repel each other. The number of positive charges and negative charges are equal on an uncharged or neutral body, and the electric charge generated by induction stays only as long as the charged object is near to it. Gold leaf electroscope. Gold leaf electroscope is the device used to detect electric charge on an object. It consists of a copper copper rod having metal disc at one end and gold leaves at other end. On touching with uncharged object, the leaves remains closed. And when charged object is touched to the disc, the leaves repel each other because same electric charge develop on both the leaves and same charges repel each other. If we touch the disc with our hand, the leaves collapse because the charge in the leaves goes into the earth through our body. Let us know how electricity is produced. Electricity can be produced in the following ways. So electricity can be produced by converting chemical energy into electric energy. It gives direct current. For example, dry cell, simple cell. Electricity can be produced by converting mechanical energy into electrical energy. And this gives alternating current. For example, generators, dynamo, windmills. Different sources of electricity are cells, battery, generator, and power stations. Lightning. Lightning is an example of static electricity. It is a gigantic electric discharge occurring between two charged clouds or between a cloud and the earth. During thunderstorm, clouds are electrically charged. Hence, a potential difference is created between clouds and the earth. This potential difference creates an electric field between earth and clouds. As a result, the negative charge jumps from cloud to the earth, and this is called light lightning. It is very dangerous and serious. Current electricity. Current electricity is made up of moving electrons or ions. In conductors, some electrons are free to move, and these electrons are called free electrons. The flow of free electrons in one direction produces electric current. Electric current is rate of flow of charge. Current is denoted by the symbol I. Current is equal to charge upon time. Charge is represented by the symbol Q and time T. So we get a relation I is equal to Q upon T. Current is equal to charge upon time. Electric current is defined as the rate of flow of charge. Current is scalar quantity because current is completely expressed by magnitude only and there is no need to tell direction. SI unit of current is ampere, SI unit of charge is coulomb and SI unit of time is second. So from the relation current is equal to charge upon time, we get the relation 1 ampere is equal to 1 coulomb upon 1 second. SI unit of electric current is ampere and the device ammeter is used to measure current. If the charge is measured in coulomb and time in second, then the unit of current is coulomb per second and it is called ampere. Thus, if the rate of flow of charge in a current is 1 coulomb in 1 second, then the current will be 1 ampere. Conventionally, the direction of electric current is always opposite to the flow of electrons. Electron flow from negative terminal to positive terminal inside the cell and current flow from positive terminal to negative terminal of the cell. The smaller unit of current to express a weak current are milliampere and microampere. 1 milliampere means 10 raised to minus 3 ampere and 1 microampere means 10 raised to minus 6 ampere. Potential difference. We know that if a body is free to fall, it will fall downwards towards the earth's surface due to gravitational field of the earth. A body always moves from higher level to the lower level. If two vessels containing water up to the different levels are joined together, the water flows from the vessel containing water at higher level to the vessel containing water at lower level. In the similar manner, if two charged conductors are joined by a metallic wire, the direction of flow of electrons is determined by a quantity called potential of the conductor. The conductor having excess of electrons is said to be at lower potential, while the conductors having deficit or less number of electrons is said to be at higher potential. In keeping with the convention of flow from higher level to lower level, the electric current is said to flow from region of higher potential to a region of lower potential. That is in the direction opposite to the direction of flow of electrons. The movement of electron continues as long as there is difference in potential between the two conductors. To get a continuous flow of current between the two conductors, a constant difference in potential has to be maintained between the conductors. Some work is always done when a charge moves from a point at higher potential to a point at lower potential. Potential at a point is defined as the amount of work done in bringing a unit positive charge from infinity to that point. Potential difference is measured using voltmeter. This is voltmeter. We can measure potential difference using galvanometer also. Using galvanometer, potential difference and current both can be measured. Potential difference is denoted by the symbol V, and potential difference is the work done when charge Q moves from one point to another. The potential difference V between 2 points is given by V is equal to W upon Q, where V stands for potential difference, W stands for work done, and Q charge. So potential difference is equal to work done upon charge. Its SI unit is volt. When current flows through a conductor, the wire offers some obstruction to the flow of current. The obstruction offered to the flow of current by wire is called resistance. A metal has large number of electrons free to move inside the metal, and these electrons are called free electrons. The motion of these electrons inside the metal wire is rapid and random. When potential difference is applied across the end of metallic wire, electrons inside the metallic wire start moving in one direction, that is towards the positive terminal. During their movement, they collide with fixed positive ions. In these collisions, electrons lose speed. Motion of electrons is opposed, and this opposition is called resistance of the conductor. Resistance is the measure of the opposition to flow of current in an electric circuit. Unit of resistance is ohm, and it is represented by the symbol omega. Symbol ohm is named after George Simon Ohm, a German physicist who studied the relationship between voltage, current, and resistance. Resistance of wire depends on following factors. First, nature of conductor. Different metals have different concentration of free electrons. A good conductor of electricity offers less resistance. Silver is the best conductor of electricity. So silver has least resistance. Length of wire. Resistance is directly proportional to the length of the wire. Long wire offers more resistance. Resistance depends on thickness of wire, and it is inversely proportional to the thickness of wire. A thick wire offers less resistance, and a thin wire offers more resistance. Resistance depends on temperature. The resistance increases with increasing temperature. SI unit of resistance is ohm, and it is denoted by the symbol omega. This is the symbol omega. Conductance is reciprocal or opposite of resistance. Resistance means opposition to the flow of current, and conduction means the property by which current is allowed to flow through the conductor. So conductance is opposite of resistance, and its unit is also opposite of unit of resistance, MHO, mho, and symbol is also opposite, Simon. Ohm's law. Ohm's law states that as long as the physical state of a conductor remains the same, the potential difference applied between the ends of a conductor bears a constant ratio to the electric current passing through it. The physical state of the conductor remains the same if its length, area of cross section, temperature, and the material remains unchanged. So Ohm's law gives a relation V upon I is equal to R. The constant in the above relation is called resistance of the conductor, and it is represented by the symbol R. The resistance of the conductor is 1 ohm if a potential difference of 1 volt applied between its end causes current of 1 ampere to flow through it. An electric circuit is a closed path along which an electric current flows from positive terminal of the battery to the negative terminal. Components of electric circuits are a source of electric current, means battery or cell, connecting wires, device which uses the electricity, for example bulb, and a key or switch. The word circuit indicates that the path of the current leads back where it is started, means it is a closed path, and that's why its name is circuit. An electric circuit consists of three main parts. The source of electric current, means battery or cell. Second, electric gadget to be used, means bulb or any gadget. And third, key or switch. Open circuit. When the switch is off, the current doesn't flow in the circuit, and such circuit is called open circuit. This is open circuit. Switch is off and circuit is not complete, and this is open circuit. Closed circuit, when the switch is on. Here the switch is on, and so the current flow through the circuit, and such circuit is called closed circuit. The source of electric current, that is battery, provides electromotive force called EMF or commonly called voltage. This force pushes the electrons that carry the charge around the circuit. The key is used to start or stop the electric current. When the key is closed, two ends of conducting wires are connected to the key get joined, and when the key is open, wires are separated. The current in the circuit flows when the circuit is closed by closing the key. The current stops flowing in the circuit when the key is open. Symbols used in electric circuits. Electric cell is represented by this symbol. This is the symbol of open switch or off switch in off position. Symbol for electric bulb. Symbol for battery. Two or more than two cells are connected serially. This is open switch, closed switch, symbol of cell, symbol of battery, symbol of lamp, symbol of fuse, symbol of voltmeter, ammeter, and if there is G, galvanometer. Cell. A cell is simply a device to maintain a difference in amount of charge between the two substances such that steady flow of current can be obtained from them. A scientist Holta designed the first cell to produce electricity, and this cell is simple voltaic cell or simple cell. Simple voltaic cell consists of two metal plates, copper plate and zinc plate. Copper plate act as positive terminal and zinc plate act as negative terminal of the cell, and there is a dilute sulfuric acid in the container. Sulfuric acid is called electrolyte. Electrolyte means the solution through which electric current can pass. So here in this cell, sulfuric acid is electrolyte and the plates are electrode, positive electrode and negative electrode. In the cell, chemical energy is converted into electric energy. Chemical reaction takes place between this acid and these metals, and in this way chemical energy free ions are produced, and these free ions can generate electric current. In this way, in cell, chemical energy is converted into electric energy. Such cells are also called as electrochemical cells. We are learning sources of electricity. Next, nuclear power station. Atomic energy is converted into electric energy at nuclear power station. Atomic energy is used to convert water into steam, and steam is used to rotate turbine. Turbines are connected to generator, and when turbines rotate, electricity is generated in generator. Windmill. In windmill, mechanical energy is converted into electric energy. Electricity is also produced from sea tides. Mechanical energy of the tidal waves is converted into electrical energy. Hydroelectric power station. At hydroelectric power station, potential energy of water stored at height first converted into kinetic energy of flowing water, and then this kinetic energy is used to rotate turbines. Kinetic energy is converted into mechanical energy, and the turbines are connected to generators, and in generator mechanical energy is converted into electric energy. Source of electricity is thermal power station. Heat energy obtained by burning of coal or other fuels is used to convert water into steam, which in turn rotate turbine. Rotating turbine start function of generator and electricity is produced. Generators. Generator is a machine that converts mechanical energy into electrical energy. It works on principle of Faraday's law of electromagnetic induction. The important elements of generator are magnetic field and motion of conductor in magnetic field. Electric generator works on the principle of electromagnetic induction. The principle of electromagnetic induction states that the change in the magnetic field around a conductor generates electric current in the circuit. Next, source of electricity is battery. A battery is simply a few secondary cells connected together. It is also called accumulator. There are lead acid accumulator and nickel cadmium accumulator. These batteries are also called storage batteries because they store electrical energy in the form of chemical energy. They are used in cars, trucks, inverters, and factories. Primary cells. The cells which cannot be recharged or reused are called primary cells. The chemical reactions are non-reversible and the cell has to be discarded when the chemical reaction stops. So we cannot use primary cell again and again. Once the chemical reaction stops, we have to throw primary cells. Secondary cells. These cells can be recharged by passing electric current through them, which causes the chemical reaction to reverse and initial substances are formed again. Such cells are called secondary cells. Secondary cells can be used again and again, and they can be recharged. When secondary cells are used, chemical energy is converted into electric energy. And when secondary cells are charged, electrical energy is converted into chemical energy. Dry cell. It is also called Lagrange cell. A French scientist, Georges Lagrange, Developed an easy to use dry cell in 1866. Dry cells are used in torches, radios, clocks, watches, remote controls, transistors. A dry cell is made up of zinc container. There is a metal body made up of zinc, and this metal body made up of zinc acts as negative electrode, and in this metal container there is a paste made up of ammonium chloride and zinc chloride, and there is a muslin cloth containing mixture of carbon, mixture of manganese dioxide, mixture of carbon and manganese dioxide, and this is placed inside the zinc container. Carbon rod, at the center there is a carbon rod, graphite rod, and graphite rod works as positive electrodes, and zinc case works as negative electrode. Electrical conductors. Electrical conductors, they are also called good conductors of electricity. Materials that allow electricity to pass through them are called good conductors of electricity. Objects that share electrons easily are good conductors of electricity. And metals share electrons easily because there are 1, 2 or 3 electrons in the outermost orbits of metals. And that's why metals share electrons easily. And so metals are good conductors of electricity. Base conductor of electricity is silver, and metals in decreasing order of their electrical conductivity are as follows. Base conductor is silver, second copper, then gold, aluminium, bronze, beryllium, magnesium, molybdenum, tungsten, zinc, cobalt, cadmium and nickel. So these are the metal arranged in the decreasing order of their electrical conductivity. Base electrical conductor is silver. And these are cadmium, nickel, these are poor conductors of electricity. Our body, seawater, impure water, mineral water, electrolytes are good conductors of electrical insulators. Materials that do not allow electricity to pass through them are called insulators. Insulators do not share electrons because there are no free electrons in insulator. For example, rubber, wood, glass, plastic, ebonine, paper, Teflon, polyethylene, PVC, cotton, air, distilled water, leather, these are all electrical insulators. They do not allow electricity to pass through them. Next, semiconductors. Materials that may or may not share electrons are called semiconductors. Semiconductors are used in electronics and in fabrication of electronic components. Silicon, germanium, gallium, arsenide, tellurium are semiconductors. Characteristics of electricity. First, electricity can be converted from one form into another form easily. It can easily transported to distant places through wires or cables. It can be generated in desired quantity with relative ease, and it is the non-polluting source of energy. Color coding of wires. Different colors are used for different wires. For example, live wire, neutral wire, earth wire. Live wire is the wire through which current enters the appliances, and color of live wire is red or brown. Neutral wire is the wire through which current leaves the appliance, and color of neutral wire is light blue or black. Earth wire protects us from getting shock, and color of earth wire is green or yellow. Fuse. Fuse is a safety device used in an electric circuit. It is the weakest point in an electric circuit which melts and opens the electric circuit when it gets overloaded. Fuse wire. Alloy of tin and lead, tin 63% and lead 3.7%, have low melting point and high resistance. Fuse wire is used in electric circuit to break the circuit when excess amount of current flow through the circuit. Miniature circuit breaker or ELCB, earth leakage circuit breaker. This device automatically switches off the main supply of the current drawn exceed and prescribe upper safe limit. The MCP replaces the main fuse. Earthing. Connecting metal body of an electric appliance with a thick copper wire whose other end is buried deep in the earth and is surrounded by a mixture of charcoal and common salt is called earthing. In earthing, there is a metal plate made up of copper and thick wire. At one end of the wire is the metal plate is connected, and other wire and the other end is buried deep in the earth and surrounded by a mixture of charcoal and common salt. Earthing protects the user by electric shock. It also protects appliance from burning out. Short circuit and overloading. Short circuit. Sometimes due to overheating of wires, the insulation melts on the live and neutral wire and they touch each other. When this happens, large amount of current flows through them. Due to almost zero resistance, heat is produced and it may lead to fire, and this is called short circuit. Overloading. Sometimes in a circuit, too many appliances are connected and operated at the same time. So large current is drawn in the wires. And when large amount of current flow through the wire, large amount of heat is generated and which lead to short circuit and electric fire. This is called overloading. Effect of electric currents. There are three effects of electric current: heating effect of electric current, magnetic effect of electric current, and chemical effect of electric. Heating effect of electric current. So heating effect of electric current states that when electric current is passed through a conductor, the conductor becomes hot after some time and produces heat. This happens due to the conversion of some electric energy passing through a conductor into heat energy. This effect of electric energy is called heating effect of current. Heating effect of electric current was discovered by James Prescott Joule, and hence it is also called Joule heating effect. Appliances based on heating effect of electric current. The following appliances are based on the principle of heating effect of electric current, and they are electric iron, electric heater, hot plate, room heater, electric geyser, immersion heater, electric toaster, electric oven, electric bulb, etc. The two common alloys used to heating elements are nichrome and manganese, because nichrome is an alloy of nickel and chromium and iron. So in nichrome alloy there is 60% nickel, 15% chromium and 25% iron. They have high resistivity. They do not get oxidized till 1000 degrees Celsius. They have fairly high melting point. Heat produced in a conductor due to electric current depends on the following factor. First, resistance of the conductor. Second, amount of heat flowing through it. And third, time for which current flow in conductor. Magnetic effect of electric current. Magnetic effect of electric current means that an electric current flowing in a wire produces magnetic field around it. Magnetic effect of electric current was discovered by Orestes, and he found that a wire carrying a current was able to deflect a magnetic. Appliances based on magnetic effect of electric current are electric bell, voltmeter, galvanometer, motor, generator, dynamo, electromagnet, television, fan, motor, etc. Next, chemical effect of electric current. When an electric current is passed through a conducting solution, some chemical reaction takes place in the solution. For example, some current is passed through water. Water ionizes into hydrogen and hydroxyl ion. Means when electric current is passed through water, its constituent element hydrogen and oxygen are separated. Chemical effect of electric current was accidentally discovered by Luigi Galvani in the year 1971. He was an Italian professor. Appliances based on chemical effect of electric current are electroplating and electroplating. The process of depositing a layer of any desired metal on another material by means of electricity is called electroplating. Electrolysis. Electrolysis is a chemical decomposition of a compound into its constituent elements brought about by a flow of electric current. Measures to save electricity. We get electric energy from coal and petroleum. These fuels will get exhausted very soon. They are formed very slow in nature over millions of years. And if these fuels get exhausted, it will affect our life. So we should understand and conserve electricity today to avoid an energy crisis. In order to conserve electricity, we must do the following things. First, switch off lights and fans and all other electric gadgets when not needed. Second, use electrical appliances that consume less energy. Power saving appliances. Use power saving appliances that consume very less amount of electricity. Next, avoid overheating water and food. Next measure is use solar appliances such as solar cooker, electric stove, solar water heater, etc. Safety rules to be followed for safe use of electricity. These are the safety rules to be followed while doing electric work. And the safety rules are: first, never put fingers or other object in an outlet. Next, disconnect the electric device before cleaning. Never turn electrical appliances with wet hand, because mineral water is good conductor of electricity and there is a possibility of getting shock. So never touch electrical appliances with wet hand. Never remove a plug by pulling the cord connected to it. Keep electrical devices and rulers away from water to prevent shock. Place dangerous appliances out of reach of small children. 7. Always use appropriate insulated rubber gloves and goggles while working with electricity. 8. Always use insulated tools while working. Don't touch someone who has been electrocuted. Thank you for watching.